Hey there, hope you're doing good. Let's continue refactoring Futurecam. We have some camera capture improvements to do here. Let's start with the third one. So the camera class has a delegate, and the delegate is implemented by the UI layer, and that's how the photography code interfaces with the UI code. So for example, if the camera wants to know which mode the user has selected, it reads this property, which is implemented in the UI, and it checks the UI and returns the mode that has been selected. Similarly, now one of the things here is a capture type. This is a technical detail. We implemented it this way because we had a debug UI that let you control this. It wasn't much use. It was as easy to change it in the code. In production apps, in the production build, the user did not get a choice between these two. He wouldn't even know what they meant. So now if you look at main controller, I'm just wondering that this should not be needed because this code doesn't belong here. It belongs in with the camera. So let's do this refactoring in 2 steps. First step, we'll delete it here and implement it in this extension. Oh. At least it is removed from the UI code. Eventually we should get rid of this extension because the point of a protocol is to just have an interface, not implementation, but we'll think about that later. Are we using it here? This will still work because it is implemented in the extension, which main controller confirms to. Okay, let's see what else we can work on. Camera.loanOS settings should call AV capture device.correct exposure. Let's see. First of all, this shouldn't be a function, it should be a property since it doesn't take any arguments and it doesn't modify the state. AV capture device.correct exposure. Camera.low noise settings should call AV capture device dot correct exposure. This is the one it should supposedly call. Oh, I think this is the code that needs to be deduped. In fact, this can be simplified. Yeah, so what we are going to do is this will take care of all these checks, because you are reading this. It will check all these three cases and return invalid, and invalid is not numeric, so this will fail, and then it will return the same thing. Okay, that looks like it's done. Okay, we have just removed the local variable. I'm a little uncomfortable about having this and this be the same name. It works, but still. We should check whether we are using ISO exposure duration or exposure target offset here. I don't think we are. Nope. Let's do Control F. Exposure duration. Yeah, we are not. What are the others? ISO and exposure target offset. Exposure target offset. Great. And then ISO. Yep. Is recording. Now this is a bigger refactoring. So basically in a camera app we have to track whether we are recording or not, right? Because the UI changes when you are recording. you get a stop button and some UI elements, let the mode selector disappear and so on. So that is in camera. So here you have an ease recording. And this is invoked by the mode classes. But the problem is you can't enforce it. C++ has friend classes where you can say that for the following classes are friends of this class and can access private functions. So you can make it private and make it a friend, but you can't in most languages including Swift. So now anybody can call this to change the recording status, anybody who has a reference to the camera. So it's effectively a global variable, which we don't want. Ideally it should be under control of the mode. So oh sheesh, this is bad. You have two variables and they are kept in sync using this setup. Okay, no, this is not a stored property, it's a computed property. So it just passes through to the other one. Now we want to change the direction of pass through. Do all the modes use this long exposure? This covers light trail and time lapse. This covers burst mode. So all of them use it. Okay, so now we'll change the implementation. Ease recording is false. So this code verifies that the current mode is the one that is in use. So if you are in, let's say, video mode and you change to, let's say, time lapse mode, the video mode should no longer act on the camera because the user is not using that mode anymore. So that's what we take care of here. So here, yeah, this is fine. Now here we need to handle the set recording or ease recording. Return mode. So private set, which means anybody can read it, but only the class can write it. Now no one can write it. The set is recording we need to work on. Okay. Who is calling set is recording? Hopefully nobody. Yes. Oh. The mode accessor, is it it's private set, which means anyone can read it. So here if you look at it, you're verifying that you're calling in main queue, and you're verifying that it has been subclassed, and this should be did set. If is recording equal to old value, return. So if you set it to the same value, the did set is invoked again, and we don't want to run these checks. So you want to check if it is the old value and then return. Then you want to get to the verification. So all this will become clear when we look at the diffs. Oh, and we have to call recording status changed. Now in the mode, earlier this was a stored, it was a computed property, which means there was no storage. When you read it, this code would execute, and whatever the return value, it would get returned. When you assign this code would execute and it would set it in camera. This was a computed property. Now it's a stored property. It has a value, false. Whenever it is set, you verify that you are in the main queue. You verify that the class has been subclassed. You handle the no op case. Then you call is recording, which would again verify main queue. If a inactive mode tried to set it, it would return. Then it would actually do the update. Then it would call this. So the save code has been moved here. This is still the last step. The sequence is still maintained. This recording status changed is the last step here. And it is still the last step here. So the chance of things going wrong is low. Move the is recording stored property from camera to mode. So actually what we want is not private set but protected set. Swift doesn't have a protected access control level. So if it is public, everyone can access it. If not, no one can. We can make this a delegate. We can make this a computed property, but then the implementation will have to be copy pasted everywhere. I still think it's better here, but is it better here? So the original motivation was to reduce the access level of this by not making it a global variable. But we haven't achieved that. It's still a global variable. Anyone who has a reference to this object, which they can get using the camera, can still change it. So have we achieved anything at all, or is this a unnecessary refactoring? Yeah, I'm not convinced this is helpful. Let's not change things for the sake of changing them. If you made a change and it's the same, it's not better. Discard it. Don't commit it to Git. So if we make it an abstract property, yeah, that also won't help. Yep, there are times when the encapsulation offered by the language is not powerful enough. Alright, what do we work on next? CL location manager dot shared. It is used only in metadata tracker. Yep. For a change, we are not working on the camera code. So the more conventional way would be to do this in the initializer. We should check what the initializer is. It doesn't have any in it. No, it doesn't. Yeah, never mind. So Swift has some funny stuff. You have to find out the superclasses designated initializer and override it. I guess it's just init. Now this need not be var anymore, it can be a let, because it's assigned in only one place. And it need not be optional as well. Is observation used? Oh, it's a global variable, not an instance variable, if you notice, which was okay in the past, but now let's write it in a more conventional object oriented style. observation is this: the first character of the second argument should be aligned with the first character of the first argument when they are on separate lines. Now you don't need this manager, you just say self. Four blank lines and a blank line here in case we had other private functions. Now dot shared. Was this the only search result? Oh, it's used in two places. So that would be a bigger refactoring. Why do we use a single instance? So you're asking for it to update location and heading, and when you do that, the callbacks are going here, which is very odd. So these two can be accessed from the location manager. So earlier we didn't have a class, it was just an extension. So we had to use a singleton instance since there wasn't any initializer. Anyway, let me just thinking about whether to revert it. I think we can just keep this shared variable here. So now if you, okay, forget this. Let's stage just this. Now you have a subclass, and initialization code should be in an initializer, not in the IIFE for the singleton, which is an odd way of doing it. Oh, this is not indented properly. I have no idea why the diff is broken, but anyway. Why is the entire thing showing as changed? Let's stage this also. Hopefully the diff tools will work better now. Yeah. You have a class level documentation, which is good, because earlier the question was, in what way is this a better location manager? And the code is the same. You still have a singleton instance. This one, instead of being a global variable, is now an instance variable, as it should be, and it's a let and it's non-optional. So this is an improvement. Make better location manager conventionally object oriented. Adhere to the convention except when you have a reason otherwise. I don't know why it sometimes says index here and working tree. Sometimes I have no clue. This was only for analytics, which is now removed. Yeah, now I think we are making progress towards not making it a singleton. We'll see. No, we are not. Anyway, never mind. Self dot delegate equal to self. So this now conforms to the delegate, or in Java speak implements the interface. It sets itself as a delegate. It implements the two functions that are needed, and it updates the local variable. This can be an extension, but we'll get to it later. These can't be in an extension since they're modifying the property. These can't be because they are stored properties. Can this be? It can't because it overrides. In fact, that's the reason we introduced a class in the first place. So let's see how our code is looking. Metadata tracker is simplified. Dead code is removed. The only thing that might be different is here it creates this object, because in Swift when you have a property like this, a static, the first time you access it, it gets initialized, which causes this observation to start happening, which takes time. So in this commit, to avoid creating a problem, I would do this. You're just accessing it and ignoring the value. This means like no variable. So this causes the initialization to not be delayed. Otherwise it will get initialized when this is read, which may be too late, because this is an asynchronous process. When you start observing the orientation of the device, it takes some time for the sensors to initialize accelerometer, gyroscope, compass, whatever. So you can't do it when you need it. You need to do it ahead of time. So this is a case where when refactoring, don't make it any worse. This may not be the best code in the world, but don't make anything worse when refactoring. The second lesson is how messy singletons are. So we really need to work on them in a future commit. Okay, now it's implementing its own delegate, setting itself, having two private set properties. They are var because they are assigned and optional. Move logic from metadata tracker to location manager that belongs in the latter. Just the way this class works is you give it some metadata and ask to update it with the information, the location and whatever, right, or the heading, etc. So it keeps observing them and storing them in a local variable. When needed, it's ready. It's the same logic, just that the location of the local variable has gone here. Okay, still a singleton. We should work on it in a future commit. Let's see what else we can work on. How long have I recorded? Oh, 45 minutes. Yeah, let's pause this video here. We'll continue in the next one.